Hello everybody, how you all doing? Hope you're having a wonderful day. It's been a week. It feels like it's been a week since we've talked. Granted, it's only been about 4 days, but still, it's been a long time. We had the extreme heat wave here in the Pacific Northwest. Most of the Pacific Northwest is still having it, but where I live, we're actually not having a heat wave right now. It's actually quite cool and pretty average, I would say. So we can actually stream. Yay! Alright, so I was giving some thought on what we should do today. And a lot of what I was thinking was... Well, I got this new game that I've been really much enjoying, and there's just problems with it that I want to fix. I can't fix it. It's not an open source game. Which would be nice. But no. So, I have to make my own. That's just going to be, the big thing. So, let's see. We're going to actually sit down and we're going to try and figure out how to make a game like Stardew Valley or, Graveyard Keeper, which is the one I'm really excited about. And hopefully we'll actually be able to make something good. So we are going to do this. I was originally thinking Unreal Engine 5 because I was thinking, hey, it's new, it's going to be great. We can do probably a great 2D game in that. I loaded up to get things started, and lo and behold, there's no 2D templates. So I'm thinking that they're just going to drop that or something. Which brings me to the next game engine on the list. Now, usually people would go, oh, go to Unity. There's lots of stuff there. I don't like Unity. Yes, I could do it in Unity, but I don't like Unity. And I would have to pay for a copy of Unity before I could even write one line of code. So no, we're not doing Unity. Instead, we're doing a free engine that is amazing in so many ways, because it can be as good as Unreal Engine or as simple as a Game Boy in terms of what you output. And it is called, I'm not sure if it's Godot or Godot, but or Godot. I don't know. I've always in my head called it Godot Engine because that sounds more fun. But Godot works too. So yeah, we're gonna be working on that. But before we do that, let's start by putting on some music. And ooh, I should do that. Yeah, I was thinking about let's put on some music, and we can it's freeware and all sorts of stuff like that. And I just realized I could put on a video game music that I really like and screw everyone else because I want to listen to it. And I don't have it on my computer. Dang it. Oh wait, there it is. My mouse is literally on it. We're going to listen to Stardew Valley music. Because this will kind of get us into that mood. Okay, it's picking up extra audio. 1 second. There we go. So yeah, we'll have that kind of going in the background. We're going to put it pretty low. Alright, so first thing to do is we are going to come up with a list of things that we need to have this game do. Not necessarily storyline stuff, but basics for the game. And let me move that logo. I'll just put it on the other side for right now. Okay, so first of all, in a game like Stardew Valley or Gravekeeper, you need to be able to collect resources. So, collect resources. Well, that's one item. Collect resources. Collect resources with tools. Let's see. You need to be able to use storage box. Maybe I should be a little bit more specific in some of these, rather than storage box, or a little bit more open, I guess I should say. Oh, and before I forget, I'm going to add all of these other tracks. And now I'm going to set this thing to shuffle. So it will randomly thing. So, access box? No. Access furniture, I guess. Access device. Access device. No. Access inventory. Access device inventory. Use device. Start auto crafting device. Let's see, we're going to need to be able to do stuff. So, let's see. Ooh, back here in the inventory. Deposit items into inventory. Withdraw items from inventory. Use item. Use device. Start auto crafting device. Let's see. And to be clear, devices can be anything from farm, planters to boxes to anything. I mean, an auto crafting device, could be the any sort of farming implement we make. Okay, so NPC reputation system. Cooking recipes, which, if you think about it, in many ways could boil down to and we actually need to consider this is let's actually take away cooking and we go crafting system, crafting items, crafting usable items. Items give stats, restore health, stamina. Alright. We also need time of day system. NPC quests, NPC trading, And I'm actually going to save this real quick. Whoop. I don't know what I'm calling this yet, so I'll just give it a basic name. I'm trying to think of what to call it, though. Alright, for now, it's just Stardew Valley clone. NPC schedule. Now, something that they did in Graveyard Keeper, which I really liked, was they had a tech tree that you had to go through. And I really liked that concept. Stardew Valley doesn't have that per se. It's more of Stardew Valley. You can actually access their stuff all the time, and all sorts of stuff. Whatever you have, you just had to get the money and get to that point where you could unlock that. But I kind of like the tech tree concept. But even then, we would want to make some techs dependent on the storyline. Let's put this up here. We'll reorganize all this later. NPC Movement. Alright, we also need ways of being able to do, like, damage. So, weapon damage, kill NPC, spawn loot, lootable no, I don't need to do lootable chests. I just need to be able to spawn loot. Yeah, it's right there. Alright, so this is where we're at, and this is still a lot. Move character. Do we want screens? I mean, if you look at Stardew Valley, you had these whole sectors that you had access to, and then you could, go to another zone, and things were completely different. But if you look at Graveyard Keeper, it's all one constant screen. Ooh, weather. So, I think a good question is, with our time of day system, do we want it to be like Stardew Valley, where, the day ends at 2 a.m., and, you're kind of screwed after that? Or do we do it, a little bit more open, where there is no go to bed time, it's whenever you want, but, you can use bed to restore stamina. Ooh, yeah, bed device restores stamina, health, and passes time. So there's a lot to do here. Plus we gotta develop the story. But let's start by getting some of these basics ready to go. And once we kind of have this basic system in, I can actually sit down and start developing the map and the characters and the storylines and all that. But I want to get all this done. We can do this on stream. And hopefully by the end of all of this, we'll actually have a game that I can just pump out on Steam and the Epic Games Store. Alright, I'm going to push this off to the side so I have access to it. I'm also going to scale it down because I don't need it as big as you guys do. Alright, so this is Godot engine. Or Godot engine. I'm not sure which it is. We are going to start a new project. I can't take it off screen and see it. Okay. Let me, because I'm going to do some file navigation. I don't want you guys to see that. Alright. Okay, here we are. It's all set. Create and edit. Alright, here we are. Create 2D scene. There we go. So I'm going to try and do as much of this as I can without needing to use tutorials or anything. And we'll just see how we go. That said, I do have... Ooh, the mermaid song. I'm gonna turn down my volume a bit. Probably turn that up a little. I do have demos, so I can get some concepts of what I want to do. But it's kind of fun just to kind of explore and figure things out on your own. Parallax background. Ooh. Alright. Node 2D. Canvas modulate. Light 2D. Light occluder 2D. So we can actually have a character have a light source and, have it, block lighting. Alright, tile map. Let's start with that, I guess. Give a tile set resource to this tile map to use its tiles. Tile set. Save resource as ground 1.0 ground 1.0 underscore tile set. Add or select a texture on the left panel to edit the tiles around it. Okay, I had a feeling something like this would happen, so I grabbed another program AS Sprite. I actually bought this on Steam. It was on sale. So, new file. RGBA. What are the advanced options? Oh, okay, pixels. Dynamics. Okay. So this I know even less about, so... Tiled in both axes. Oh, okay. Alright, so it's not great, but as a first pass, not bad. Sort and gradients. Ooh. New layer. Can I... Properties. Opacity. Ooh, yes, please. Because I think this whole thing needs to be darkened. Is there like a pen tool where I can just delete? Ah. No. Edit color, sort and gradients, presets, options. Ah, there we go. E. Ah, yeah, over there. Okay. Ah. Alright, that's pretty good. So let's start taking away just a little bit. Okay. It's good to go. Hey, Mythos, how you doing? Sorry, just a little distracted. It always happens. Oh, good. Okay, I think this is, yeah, that's good. That'll be a good starter. Yes, focused. That usually happens with me, unless I have a lot of people that I'm already talking with. I tend to get pretty focused and end up, where the heck is this going? Oh, it's going to my documents folder? And I can't take this off screen. Alright. So, whole program goes off screen as I change the directory and share this. New folder, call this sprites. Graphics. Alright. We'll call this grass underscore V01. PNG, I guess? Oh, I prefer Targas. Yes, please. Oh, do they have PSDs? I'm not entirely certain, because, the first thing that happened was, I realized we needed some tiles. No. So, grass underscore V01 to say okay. I'm assuming it's going to save on the right one. Yeah, ray trace grass. That's right. That's what I got to do. All right, export. Yeah, there we go. Yes, I want to do that. Okay, there we go. So now that we have our first grass tile, and it's crap grass, but at least we can tell it's grass. Let's load up the Godot engine. I'm going to remove that icon and add our grass icon from, I'm not sure where it's telling me to go. Ah, okay. All right. All right. Tile sets grass version 1. There we are. All right. So now I have my first tile set. So now I can go to my tile map. I can take my ground. Open. Edit. New single tile. I think so. All right. There we go. Okay, so selected name grass v1. Normal map, none. Material, okay. I feel like I'm I feel like I probably need to do a tutorial on this. So let's see what Godot has to say. Creating a tile set. All right, using tile maps. There we go. All right, so a tile map is a grid of tiles used to create blah blah blah. Project setup. At this demo, we're going to be okay. They're using a side scroller. I want like a top down. So, okay, when using a tile set, it's important that adjacent tiles match up. All right, add a new tile map node to the scene. By default, the tile map uses a square of grids. You can also use perspective-based isometric mode or define your own custom tile shape. Okay. So, tile map, isometric, we'll probably have to do custom. Load a tile set. We'll use that tile set. That's not right. Alright, so edit, collision. Nope, let's delete that. Occlusion, navigation. Alright, let's go back to our tile map. Something's not right. Ah, there we go. So now we can basically draw our whole tile map. I'm assuming this blue line kind of indicates where the... Can I, like, have a larger paintbrush? Nope. Nope. Custom transforms. Let's change these to 32. Okay, right-clicking will delete them. Left-clicking just adds... I guess I just have to... There's no fill tool or anything. I just have to manually do it. That's okay. I probably would have to do that anyways. At some point. Alright, so. Alright, transform Z. Visibility. Ooh. Materials. Alright. Quadrant size. 16's fine. Alright. Y sort. Oh. Causes the tiles to be drawn in the order of their Y position so that lower tiles are drawn on top of higher ones. So no, actually I want the opposite of that. Or maybe, yeah, I don't know. Half offset. Ah. Yeah, okay. Quadrant. Defines the chunk size used for batch drawing. This can negatively affect your performance. Don't change it unless you know what you're doing. Custom transform. Use it to alter the tile shapes. Use this if you have non-square tiles. Alright. So we don't have to touch that. Alright. So... Okay. Alright, all regular 2D modes, such as Node 2D or Control, both inherit from Canvas item, which is the base item for all 2D nodes. Canvas items can be arranged in trees. Usually, though, we don't want everything in the game or app to be subject to the canvas transform. Examples of this are parallax backgrounds, UI, transitions. Alright, the answer is to have a canvas layer, which is a node that adds a separate 2D rendering for all its children and grandchildren. Okay. So... canvas layers. Alright, let's try adding a canvas layer just straight. No? Okay. And we'll add, so we'll call this one canvas layer underscore background or environment. Let's add another one. Canvas layer, we'll make this UI. And we'll just make sure that this one stays on top. So if when we need to do UI, we'll just kind of put it under there. Okay. Viewport. Viewport size. Own world. Scene route. Let's see, scene routes. I guess world environments? I don't know. Make scene route. There we go. Okay. Follow viewport. No. Layer 1. Yeah, it does 2D, it does 3D. I mean, if we switch to 3D mode, you know, we could be working in that. It's got its scripts, an asset library, a 2D mode, and the whole thing actually comes as a single executable, and it just runs off of this. This is like 70 megs, and that contains the entire engine. Yeah. I don't know where my... Why am I... Enable? No. Alright, I think I did something wrong here. Alright. Didn't want to do this, but... Oh, I'm not sure. Let me take a look. Well, at the moment it's taking about 200 megs of memory and virtually no CPU power. But, you know, granted, you know, I don't have like a big heavy scene. Let me actually try opening up one of their scenes. I actually have a whole bunch of demos, and I actually want to take a look at some of these. All right. Project. There we go. Open project folder. Quit to projects list. Yeah, we'll save it. No, cancel. We won't save. I'll just come back to this. Quit the project list. Don't save. Oh, I can do it from zip files. Oh, I tried it into a solid. Okay. Unable to load add-on plugin. Alright, controls. WASD to move, space to jump. T to toggle linear rods. Alright, it didn't actually load from the zip file. What it did was it actually unloaded from the zip file. Okay, so we now have this demo loaded, and let's see, what's Godot running now? 1.7% of my CPU usage and 202 megs. Let's run it. Actually run it, though. Okay. Shift to walk. T to toggle. Alright, so. Okay. It has others. Including a side view. Oh, I can fly. Okay. This isn't quite what I wanted, but it's still actually pretty good. This one's just a little weird. Okay. Okay. So, that is interesting. I downloaded a whole bunch of 2D things. So let's try this next one that I think is probably going to be closest without going over. Quit the project manager. Import. Probably 2D role-playing game. Yeah. Slash 2D. Yeah. Alright, create folder. 2D. Oh, wait. Demos. 2D underscore RPG. Select file. Import. Alright. So here we are. Alright, this looks closer. Just some object. Okay. Okay, yeah, this is actually very much what we want in terms of some gay. Hey, it's good to have time to... Hey, it's a good time to have an JRPG fight, right? Let me introduce yourself to... I'm the opponent! Enough talking, let's fight! Attack! Alright. Defend. Attack. 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 Congratulations, you won! Just some object. Flee. Haha, I won. Maybe you can try next time. So, this actually looks pretty good. And you'll notice that the little triangle just kind of can go past some of this stuff. So, with a little bit of work, we could probably get it to, have a lot of fun. But yeah. But as a basic, this actually looks like it might be what we need to do. Alright, so they have a node here. It's their own script. Okay. And it looks like they have multiple different script types. This one's, GD, whatever that is. Okay, so you have a node at the top, which looks like it has most of the big stuff. I mean, here we got. Yeah. Online docs. Godot docs. Alright, development, compelling game, editor, engine, file formats. Shading, networking. I do want to do... They have VR in this? Nice. Search help. GDI script. Alright, let me look up coding. I know that for the C# version, you have to get the mono version of the program. Okay, scripting. Here we are. GD scripting. See GD script grammar if you're interested in writing a third party. They have GD script, visual script, C#, cross-language scripting, and creating script templates. Visual scripting. Tool designed to make entry barrier to programming much lower. Blah, blah, blah. Da, da, da. Yeah, it doesn't scale well. Thought so. Getting started. Okay, look at this. So... It's clearly they have their own version of blueprints going on, so I'm perfectly fine with that. Visual scripting integrates so well to Godot that it's hard to believe it was added only in version 3. Hi there, push me. Okay, so in GD script, let's go through the basics. High-level dynamically typed programming language. Use a similar context to Python. Yeah, that looks like Python, all right. But like with a hint of C++. Alright, C# basics. Ah. Nice part about Godot is that it's actually an open source engine. Okay, you need the mono if you're... Alright. So it looks like they've updated the project so it can run C# with the default model. It doesn't require the mono version anymore. And that's apparently a recent change. Cross-language scripting. Allows you to mix and match scripting languages to suit your needs. This means a single project can define nodes in both C# and GD script. This page will go through the possible interactions of the two. I'm not seeing any C++ templates or anything. Huh. Tutorials. Math. Okay. Getting started. Step by step. Scenes and nodes. Instancing. My games are exquisite. Okay, I'm not sure I can... Oh, alright. Start with the basics. Nodes are a fundamental building block. Alright. Any given node always has the following attributes. A name, editable parameters. It can receive callbacks to process every frame. It can be extended to have more functions. It can be added to another node as a child. That last one is important. Nodes can have other nodes as children. When arranged this way, the nodes become a tree. In Godot, the ability to arrange nodes this way creates a powerful tool for organizing projects, since different nodes have different functions, and combining them will allow for the creation of complex functions. Okay. Basically, Godot is a scene editor. So you're basically editing a bunch of nodes. Note in an empty scene without a root node, a scene is docked. Okay. 2D scene adds a node 2D node. 3D scene adds a spatial node. User interface adds a control node. And other node lets you select any node, so it was equivalent of pressing the add child node. Alright. You can press the star shape icon to toggle the display of your favorite nodes. Yeah, I don't have any, because I just started. Now to add a label. So you can add just a straight up basic node. But we're looking specifically for a label. Alright, well, let's try this. New project, hello world. I want to constantly choose up. Create folder. Hello world. Use selected world. Create and edit. Alright. So, let's create a new label. There we are. Text. Hello world. File save. Call this, yeah. Label underscore hello world. There we go. We built our game. Our hello world game. So, now let's package it up and put it on Steam. No, we got more to do. Play of the game! Okay, we could probably... Can we expand upon this? Percent visible. We want it all visible. But, how do we, like, make this bigger? Okay, well, we can edit text bigger. Alright, grow direction, size flags, fill. Okay. Custom styles. Neat. Custom fonts. New dynamic font. Load. New bitmap font. No. Oh, custom colors. Input, mouse, focus, hint, rectangle. Nerds. All right. There. Now it's in the center. But I still got to figure out how to make it bigger. So I guess what I got to do is have a new bitmap font. Dynamic font? Alright, let's just load a font. So it looks like in order to really do anything, you got to have it local. So, well, let me go to my resources, grab a font. Now, from my collection of 6,282. You, whatever the heck you are. Alright, let's, where did I put this? I put this under projects. Alright. Maybe. No. Didn't even know I had that font. That's weird. You know, that's a good one. Let's go do that one. So load. So you can't just You gotta have a .font file, huh? You can't use a TTF, huh? Alright, well, let's take a look for that. Let's go to Godot. Let's look up Godot fonts. How do you bring fonts into Godot 3.0? There we go. Copy your TTF. You'll see Godot imported as a dynamic font type. Ah, there we are. In the inspector, save as. Okay. Load Puff Trez. Okay. All right. Thank you. Catch you later. And thanks for coming by. And thank you for the follow. Welcome to the KJ crew. I will be back on Friday at 8 p.m. Pacific time. If you want to come by. Dynamic font does not... What the heck? Okay. Alright. And in the inspector, click on the new resource. Well, let's remove that. New dynamic font. Alright, here we are. Dynamic font. Alright. In the font category, click on and choose save the dynamic font under the name you want, optional. Font path. There we go. Make it unique first. How do I do that? Setting, size, okay, that's all good. set source resource to local. Okay. Alright, so now I can come here and load my new dynamic font. No. Okay. Copy. All right. Let's start kind of over. Okay. New dynamic font. There we go. Custom font. Load. New dynamic font. I don't know why it's not working with my font. All right. Okay. New dynamic font res. And we want it to be this. Okay, now it's actually showing up. So there's just something with that other one. So save. Custom fonts. All right, there we are. Custom constants. Center, center. Okay. So there we go. We were able to actually import to the font. I don't know why that other font didn't work. That was weird. Ah, more thirsty. Alright, so we got that to work, so that's the good news. So now configuring the project. Okay, it's time to configure the project. Right now, the only way to run something is to execute the current scene. Projects, however, may have several scenes, so one of them must be set as the main scene. So, project settings. Run, main scene, hello world scene. Now with this change, when you press the regular play button, or F5, this scene will run no matter which scene is currently being active. Okay. Play the project. There we go. Okay. Alright, so now we're into the next section of instancing. You can create as many scenes as you would like and save them to the disk. Scenes saved in this manner are called packed scenes and have a TCM file name extension. Okay, so basically what I created was its own independent scene, and now I can actually add that as a instance here. I can't. I got caught. Okay. Let's see. Where was I? Instancing. Okay, so I can add it as an instance to another scene. That's good to know. Import the instancing app. Bunch of walls. I'm assuming the walls are an individual scene. Alright. Ball scene and main scene. The ball uses a rigid body 2D to provide physics behavior, while the main scene has a set of obstacles for the ball to collide with using static 2D body. So the ball would come and just kind of land in here. We want to add the instance of the ball scene as a child of main. Click the link shaped icon over, so that button. Okay. Place the ball in the top left corner of the screen. This is 0, 0. Okay. Press play and watch the ball fall down. Okay. Nice. Editing instances. Ooh. Nice. Okay. Okay. HUD, player, terrain, vase, table, chair, room, door, house, seat, church, cathedral, house goes to cathedral, guards goes to cathedral, and then bridge, player, and HUD are all in part of terrain. Okay. Example of an open world type game with lots of assets and nested elements. Alright. Take a look at the room element. Let's say we start there. We could make a couple of different room scenes with different arrangements of furniture, also scenes in them. Later we could make a house scene connecting rooms to make up its interior. Then we can make a citadel scene, which is made out of many instance houses. Then we could start working on the world map terrain, adding a citadel onto it. Later we would create scenes that represent guards and other NPCs and add them to the citadel as well. Okay. Scripting. Okay. The main languages of Godot are GDScript and Visual Script. The main reason to choose them is their level of integration with Godot, as this makes experience smoother. Both have slick editor integrations, while C++ and C++ need to be edited in a separate IDE. If you're a big fan of statically typed languages, go with C# and C++ instead. That might be a good idea. I mean, it'll help me. It's a little bit easier to do some things so that way I don't have to learn, two new languages. GD Native / C++. One of our brightest additions to the 3.0s, GD Native allows scripting with C++ without needing to recompile or even restart Godot. Any C++ version can be used, and mixing compiler. Okay. Alright, so scene setup. Alright, so let's quit to the project list, and I'm going to make a new one called alright, new project. Scripting. Okay. If you still have the instancing project, close that out, quit the project list, and create a new project. Use the Add Child node. Panel. Label. Button. Okay, use the 2D editor to position and resize the buttons. Label. This is a label. Press B. Finally, save the scene with the say hello script. Okay, so save scene as say hello. Okay, adding a script. Right-click on the panel node and then attach script from the context menu. Attach script. I'm going to go with native script. Well, actually, the script name will tell in GD script. The file itself represents the class, So the class name is not field is not editable. The node we're going to attach. Okay, so say hello GD. So class name, we'll just call this say hello. So now we're here. Okay. Can I? Yeah, I can. Okay, detach script. Attach script. Let's go GD. Oh, look at that. It's ready to go. The script will be attached to the panel. Yeah, let's close that. All right. All right, there's not much here. Let's see. Oh, when we click on this... Ah, script. There we are. The role of the script. Script node. I love this graphic they have here. All right, so... Thank you. It was cold down there. Handling a signal. Signals are emitted. All right, so over there, signals. All right, so I understand what a signal is. So select the button node in the tree and select the node tab way over here. Make sure that you have signals selected and not groups. If you then select the pressed under base and then connect, you'll open up the bridge connector. Oh, nice. All right. All right, delete everything except extends panels. All right, get underscore node button. Next, we will write the function get underscore node label dot text equals hello. Why is that red? Okay. This because it was capitalized. Gotcha. Can I scale this up? Yes, I can. Good. Finally, connect. Okay. So I didn't need to write that earlier. I needed to write this. Okay. Connect. Pressed. Self. On button pressed. Okay. Okay. Alright, let's run the scene. Press me. Hello. Okay. Alright, we just finished writing our first script. So, if I were to add okay. GD script's not that hard. C# might be better at some things. Journey of the Prairie King. You gotta love it when a game has a game inside it. Alright. A common misunderstanding regarding this tutorial is how getNodePath works. For a given node, getNodePath searches its immediate children. In the code above, it means that this button must be a child of the panel. Oh. If a button were instead a child of a label, the code to contain it would be, you know, label/button. So that's a good thing to know. It's relative. Alright. Several actions are triggered by callbacks or virtual functions, so there's no need to write code that runs all the time. Okay. Alright, this method is called... Okay. Process delta, do something. Alright. Alright, it looks like this is this is a big, you know, aspect of the game. Okay, so okay. So we've got a first game here, and it's basically a survival game. How long can you last? Dodge the creeps is what the game is called. Your character must move and avoid the enemies for as long as possible. And they have a little preview of what it should look like. You know, it's just, you know, this little video. You know. Why 2D? 3D games are much more complex than 2D ones. You should stick to 2D until you have a good understanding of the basic game development process and how to use Godot. That's okay, what we want's 2D. Alright. I want a snack. Project setup. Stodge. You know, I kind of like, you know, I feel like I have a good idea for the basics, so, do they have like a recent, oh, they have version control, nice. Wait, what? Okay, set up version control, shut down. I thought it said shut up version control. Alright, quit the projects, yes, we're going to go back to Our it's not listed on here. Oh, there it is. All right, there we go. Okay, so create a new node. We'll give it a new name. We'll call this Game World. New script. Okay, so there, we got a script, we got Game World set up. So save this scene as Game World scene. So this will be our overarching, world. This is where all of this is going to be dealt with. All we have to do now is build all the sub tiers. So new scene. Yeah, let's kind of look at this. Other nodes. Player, animation, all right. Add an area 2D. Rename this player. Has no shape. Okay. Now that we set the scene's root node, we can add additional nodes to give it more functionality. Before we add any children to the... let's just save this before I forget. Alright. Before we add any children to the player node, we want to make sure we don't accidentally move or resize them by clicking on them. Select. There we go. Save the scene. All right. Oops. All right. For this project, we will be following the naming conventions. All right. Sprite Animation. So let's actually come in here. We'll go new. Yeah, I think maybe 64 by 64. No. 64 by 128. No, it's got to be bigger than that. Canvas size. There we are. Let's do 128. Yeah, let's just do 128. We'll just make it square. So let's start with a very simple kind of character. Oh, I don't have anything. I don't have anything. No. Um... Yeah, I'm good with that. So we'll eventually, make all sorts of changes. All right. We're actually going to create a new layer now. You can now see the horror that is my ability to draw. At least with a mouse. I mean, I really like this side, so. But yeah, this is just to kind of get us going. So I'm actually going to... I really hate this leg. There we go. All right, let's create a new layer. We'll call this color. And we'll just use a fill bucket. Refer to visible layers. There we go. So here we have the front-facing version of our character. You know, I'm actually going to move this up. How do I move this up? Good enough. Okay. Undo, go back to color. All right, go back to black. There we go. This terrible, hideous abomination is now our player. We will probably have another stream where we're going to like focus on this, try and figure out what a character looks like, but let's just get something that, you know, does stuff for right now. Okay. So, this is our sprite. Let's do a new frame. Yeah, we're going to do frames here. So this is now going to be the side view. Crap. Okay, that's where his foot is, right? Yeah. Alright, so okay. So that means his butt's got to be more here. This is leg. So let's come in here, clean this up. Let's just make it a little bit simpler. Not so much of a butt. All right. Yep, undo. Gotta pin this. All right. New frame. Alright, so that's good. Now come down here to color. Oh. Gotta be the whole head. Alright. New frame. Now this one we're actually going to fill in basically, you know, everything. This is going to be pretty shadowed. This is going to show that his back's to us, basically. Oop. A little bit got away from me. So there we go. There's his back to us. There's his front. I mean, I suppose I should probably swap the whole image, which kind of ruins all my painting, but oh well. Nah. Actually, yes. Flip horizontal. There we go. Oh. All right, flip horizontal, Shift H. Shift H. Shift H. Shift H. Shift H. There we go. Let's save this as car base care version 01. 01. 001. All right, new tile sets. Grassy. Save that there. Close that. All right. Export sprite sheet. By rows, constraints, merge duplicates, ignore empties, vertical, horizontal, by rows, all, yep, that's all good. No, that's not trim. Let's just do that. I mean, can I do this as a sprite sheet? I don't know. Let's find out. New folder. Players. Characters. New folder. Base car. Base character. Open in File Manager. There we go. Okay. So now we're back to the actual tutorial. Now that I have some characters. Okay. Click on the player node and add the animated sprite node as a child. Alright, so animated sprite. Create. Notice there's a warning symbol next to the node. An animated sprite requires sprite frames resource, which is a list of animations it can display. To create one, find the frames property, create new sprite frame, delete. Oop. Animated sprite, alright. Alright. On the left is click on animations. Click on the default one and rename it to walk. Then click on the new animation button. I'm going to call this up. Find the player images. Horizontal, vertical is 1. Don't undo. Yeah, I want to do that. Okay. All right. I'll call this down. Left. Right. And for this, I'm going to use camera left, camera right. Otherwise known as stage right. Down, up, left, and right. Good. Base, character, sprite frames. Okay. Alright, the player image is a bit too large. Click on the animated sprite and scale it down. No, I don't need to do that. Not yet. Finally, add a collision shape 2D as a child of the player. Collision shape 2D. New capsule. Let's set that to 2. All right. And I'm going to actually make this a little bit bigger and shrink it. Because this isn't exactly showing, what I wanted to show. Let's go down. There you go. Yeah, that's... That'll be good. Oh, gravity. Let's turn that off. Because I don't need gravity. Where we're going, we don't need gravity. Oh, my penis is small! Whoa. When you're finished, your player scene should look like this. Good enough. Project settings. Physics. No. Input. Input map's going to be necessary, but... Alright, here we are. 2D. Skinning, subsurface scattering. We'll have to test that. Use software skinning. VRAM compression, limits batching, environment. Yeah, I'll have to check and see if there's a Alright, so select the player. Okay. Scale, rotation, no, that's all clear. Alright. Player. Add a script. Alright, extend it. Export var speed equals 400. Movement in pixels per second. Var screen underscore size. Save the game window. Let's see. Size of the game window. There we are. Screen underscore size equals get underscore viewport rectangle size. Okay, now we can use the process function, which is currently disabled. So what we're going to do here is check for input, given the direction, play the appropriate animation. So, yeah, even in our version of the game, that sounds right. So, I'm going to guess that we don't need pass. So, var velocity equals vector 2. If input is action pressed UI underscore right, quote, velocity dot x plus equals 1. So now duplicate this a bunch. First one is going to be minus if we press right or left. And then it's y and y. Down, up. I'm not sure down and up or right. I might flop that, but okay. If velocity length is greater than 0, velocity equals velocity dot normalized times speed. Percent animated sprite. Okay. Play. Else. Animated sprite. Stop. I feel like there's more to this than that. Animated sprite. Add child. Animation. Is there a set? No, okay. Set. Alright, animated sprite. Animation. Yeah, we need to be. We need a way of saying. We need to be able to set the animation. Animation. Find. I hope that's right. I have no idea. Let's take a quick look, see if that is right. Winter Ancient. It's very good. Okay, so it looks like we can just do straight up, is right. That looks right. All right. Okay. So the $sign is shorthand for get node. All right. Okay, so position plus equals velocity times delta. That's an easy one. Alright, looks like he clamps it to the screen. Yeah, let's do that too. At least right now. Position X equals clamp position dot X 0 screen size dot X Y. Save. All right. Click play screen. Play scene. To confirm you can move the character. Hey! Look, I can move the character. Yep, he is moving too. Alright. And he's moving the correct ways, too. So, that's good, but it's, if, is action just pressed? We want, is underscore action pressed. I think that was probably a mistake I made. Yeah, that's a mistake I made. So if I do this again, yeah, look at that. Ooh, boy, he is moving. All right, let's plus animated sprite Alright, let's just add 64. Actually, no, 32. Since that's what we made the size, half of it, actually. Alright, so if I play this again, yep, that's as far up as I can go. Although I think I'm going to make this probably 16. Yep. Nope. Let's make this 24. Yeah, that looks good. Okay, I think he's moving too quickly. But that's just one of those instances where I'm going to just change this. Let's take it to, like, say, 120. Uh, 200? Yeah, that looks good. And we'll have to probably make changes to this. So, our character can now move about the world. Yay! Ah! Yeah, just a little bit later on, they got into choosing animations. When you're sure the movement is working correctly, add this to the line to ready, so the player will be hidden when the game starts. Okay. Hide. At the top. Alright, so signal hit. Looks like we're adding a new signal here. Ooh, okay. Sorry. Alright. Okay, so this defines the custom signal hit that we will have when our player emits send out when it collides with an enemy. We will use Area 2D to detect the collision, select the player node, and click the Node tab. Body entered. Let's see. Notice our custom hit signal is there as well. Yeah. Since our enemies are going to be rigid 2D nodes, rigid body 2D nodes, we want body entered node signal. This signal will emit. So connect We don't need to change any of these settings, so just hit connect again. Alright, so hide, emit signal, hit. Oh, no. Collision shape 2D, set deferred, disable, true. Needs to be a quotes around it. So each time the player is hit, the signal is going to be emitted. We need to disable the player's collision so that we don't trigger the hit signal more than once. Disabling area's collision can cause an error if this happens in the middle of the engine collision processing. Use set deferred tells Godot to wait to disable the shape until it's safe to do so. So this would be a section where we actually want to come back to when we start getting into, battle hits. But still, you know what? I kind of like this. This is a pretty simple setup. Alright, so now they want to move us to the enemy scene. So, every game has slimes. Let's add a slime. So let's do I think we're doing 64 by 64s. Well, this guy can be 32 by 32. We'll start with we'll just make it a blue slime. All right. So slimes are going to be just a little... Oh. Well, you know what? Screw it. Yeah, let's do it this way. Okay. Now we'll come in here, do some pen work and some eraser work. What, is there a shortcut key? Yes, E and B. Alright, what's the fill button? G. Alright. Starting. Shape. Copy, paste. That looks awful. That just... Yeah, that just looks awful. Okay, so let's start with a kind of a roundish bottom. We'll have a nice round top. Okay. Yeah. We can work with something like this. Okay, so let's take the opacity down. Alright, so now, new layer, highlight, alright, new layer, shadows, This tool will definitely come in useful later. Alright, well, as a starter... Alright. Select, inverse, delete. I don't know, maybe we should make a 3D one. Alright, we'll just call this starter slime. Save as backup. New folder. Enemies. Slimes. Blue slime. 01. Alright, export. Okay. Enemies. Slimes. New slime. That's not the, and I'm not, saying we're gonna, definitely have, all the slimes here. Okay, yeah, I can't do that. All right. I'm just saying that, we're gonna, have a slime, and we might expand upon this later. We're definitely gonna come back and fix this. Yeah, this looks like a crappy slime. Okay, let's get back into here. We should now have enemies, slimes, blue slime. Okay, so I'm going to move this into the base character. Alright, new scene. Rigid body 2D. And we're gonna, I'm just gonna, make this interesting. Alright. I'm gonna follow the tutorial, and we'll look at, additional stuff later. So, animated sprite. Add child node. Collision shape 2D. Add child. Visibility notifier 2D. Yes. Okay. Don't forget to set the children so they can't be selected like you did in the player scene. Okay. Alright, so in rigid body, in the rigid body 2D properties, set gravity scale to 0 so the mob will not fall downwards. In addition, under Physics Body 2D section, click the mask icon. Click on the mask property. Light mask? Oh, collision. Alright, there we go. Uncheck the first box. This will ensure mobs do not collide with each other. Okay. Alright. All right. Okay, set up the animated sprite like you did. This time we have 3 animations. Okay, so I'm only going to have 2, and they're both going to be the same, so. Alright, animation will be idle. Was there something I missed where it adjusted the quality? Project setup. Yes, I did miss stuff. Alright. Project settings, display, window, here we are, width. Well, they want me to do 480, but I'm gonna be per pixel technology, allowed and enabled. I hope that was right. Godot nearest neighbor. Double click the texture in the Explorer. Double click on the texture in the File Explorer. And open the Import tab. Ah, here we are. Disable filtering. Admit maps and re-import. There we go. That looks better. All right. Good enough. So, in this first iteration of the game, what's going to happen is these slimes are going to bounce around or just go through the level, and we're going to try and dodge them. If we get hit, we die. If we die, he dies. $2D, keep, okay, oh, cool, all right. Okay, so add a script. Extends, okay. Export var min speed equals 150. Export var max speed equals 250. We'll probably play with this because we did kind of change up our character. He's supposed to be moving, quite a bit more. So let's actually... Now let's just leave that alone for right now. Alright, so now we're up to the ready function, which is, in Unreal Engine's term, on begin play. So we're looking at var mob underscore types equals animated sprite dot frames. It's like get animation names. Animated sprite dot animation equals mob types rand I and we'll modulate that by mob types size. So it's gonna basically get a random integer and then divide that by the mob size. It's gonna find a random integer somewhere between 0 and mob size, and it's gonna choose a random animation. That's what it's doing. It's choosing a random animation. So it's gonna start on that. All right. All right. First, we get the yep. Okay. Then we pick a random number. Yep. Last piece is to get the mobs to delete themselves when they leave the screen. Connect screen exited signal. All right, so node visibility. Now screen exit. I'm not seeing screen exit. Am I on the right thing? Add a script to the... Yeah. Connect screen exited. There is no screen exited. Oh, visibility notifier. Okay. Screen exited. Connect to slime. There we go. Queue free. So basically it's going to say, hey, delete me. Right? This completes the mob scene. Alright. Slime's done. Okay, there we go. So now we're into game world. Create a new seed and add a node name. Ensure that the node is not a node 2D. Click the instance button. Instance. And choose player. Okay. Now add the following nodes as a child of main. Name as a... Bump, bump, bump. Alright, so now we need timer. What's the duplicate? Control D. They want the D. Mob timer. Score timer. Start timer. Start timer. There we go. Actually finally finished typing it correctly. Alright, position 2D. Oh, no, that's a child of that. Start position. Alright, set the wait time of each property of the timer. Let's get back over here. As follows. Mob timer, 0.05. Score timer, 1. Start timer, 2. In addition, set the one shot to the start timer to on, and set the position, start position, to the middle of the goddamn screen. So they wanted 240, so 2080 divided by 2. 640. 720 divided by 2. I like that I can do math in here. Spawn more overlords. Okay, that's what we're up to. We're spawning overlords. Alright, the main node will be spawning mobs. We want them to appear at a random location at the edge of the screen. Add a path 2D node. Path 2D. Oh. Named mob child as a parent of main. Alright. Mob path. Okay, so select points. Alright, so alright, select add point and draw the path by clicking to the points of the corners shown. Ah, we can actually enable a snap grid. One, two. Click close curve. Now that the path is defined, add a path follow 2D node as a child of mob path and name it mob spawn location. This node will automatically rotate and follow the path as it moves, so we can use it to randomly position and direction along the path. Oh, randomly select a position and direction. Ah. Okay, so player, timers, start position, mob path, mob spawn location. Yeah, this is all right. All right. Add a script to the main. All right. Export packed scene var mob var score randomize. All right. So what is this pack scene var mob? Okay, so so now if we come back here, we have a mob. So now we can actually select the slime mob and drop it in here. Okay. Nice. Next, select the player node in the scene dock. And access the node dock. Make sure you have the signals tab selected in the node dock. You should see a list of signals. Find and double click the hit signal in the list. Or right-click connect. This will open the diag. We want to make a new function called game. Oh, wait, what? All right. All right. All right. Game over. And click connect. Ah. Okay, so putting it out here, that's good to know. Alright, add the following code to the new function as well as a new game function. Alright, so game over, percentage, score timer, stop, stop, stop it, stop. And then we also want mob timer. So we're going to stop the mobs if we've died. We also need the function new game. Score equals 0. Player start position position 2D or just position. Oh, it's just funk, not funk new. Okay. There we go. Okay. And then we want to start timer. Start. Now connect the timeout signal of each function to the main script. All right. On start timer pass out, mob timer start score timer start. All right. On score timer timeout, score plus equals 1. So you get a score for every second, a point for every second that you survive on this particular game. All right, now for the mob timeout timer. This one's going to be, you know, a big trick. All right. So, first things first, we got to choose a random location to spawn the mob at. So, mob path spawn location offset equals rand I. Interesting, it's a integer. So now we need to create an instance of the mob. So var mob equals mob instance. Add child mob var direction equals mob path spawn location rotation plus pi divided by 2. Mob position equals mob path spawn location position. Now we add some randomness. Direction plus equals rand range negative pi divided by 4 pi divided by 4. Okay, that's a weird choice, but whatever. Mob rotation equals direction mob linear velocity equals vector to rand range mob min speed mob max speed zero. All right, mob linear velocity. So first we, find a random x value. It looks like. equals rotated direction. All right. That's it. Ah, okay. So this uses radians, not degrees. All right. So let's see if this is actually working before we have to do anything else. New game. And play. Let's also assign main as our main scene, the one that automatically runs. Press the play button. Resizable. Always on top. Yes. Am I putting the position in the wrong spot? There. I think their script was wrong. Or did I just... No. I'm pretty certain their script is wrong. Well, the slimes are here. But I couldn't see the player. So, let's get back into script. New game. Score equals 0. Position equals the start position. Which, you know... Okay, yeah, that should work. I'm going to actually stop that. Alright, what happens if I turn that off? Oh, you know what? Player show. I mean, yeah, unless I missed something, I don't think the player has a start function. Alright, let's try this. There we go. So now that that's working, we can start to put the timer back. Oh shit. Slimes everywhere. Oh, I died. Okay, so we are definitely having problems with the mob timer. 0.0, no, 0.5. No wonder that was insane. Yeah, that's more manageable. You know, with some graphics changes, I could just throw this up on the iOS store. Alright, I am definitely going to make this faster. Let's do 0.1. So it's not going to be 0.05, but it should still be quite intense. Yikes. Yeah, this is the intense level. Ah, okay. Okay, so let's 0.5 is just way too easy. So I think let's try 0.25. Yeah, this is challenging but not hard. Yeah, okay. So like a first level, this wouldn't be bad at this resolution. So those two things are going to be tied together, basically. Okay, so now for the final piece of the game, the HUD. So, interface display, associating the games, okay, blah, blah, blah. Create a new scene. And add a canvas layer node. Canvas layer node. Call this HUD. Bum, 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 bum. All right. Canvas layer node lets us draw our UI elements on a layer above the rest of the game so that the information it displays isn't covered up by any game elements like the player or the mobs. The HUD needs to display the following information: the score, changed by score timer, a message saying game over or get ready, and a start button to begin the game. The basic node UI, alright. So we need to create some child nodes. We'll start with labels. Alright, so score label. Message. A button. Start button. And a timer. message timer. Click on the score label and type a number into the... Okay. The default font for control nodes is small and doesn't scale well. There is a font file included in the game access, Zonium Regular, TTF. Well, it looks like we're going back to, figuring out the fonts. And I'm just going to create a new folder and then open up my huge collection of fonts. I mean, there's literally thousands and thousands of fonts here. No. Let's actually do this with extra large icons. First sortie. You know what? I kind of like this. All right. To use this font, okay. Choose fonts. Select. Choose new dynamic font. All right. You may set the font size to 64. I'm going to put it over here. Okay, so I'll have this over here and pretty big in case, something good happens. Alright, so save, play scene. Yeah, that looks good. How's that? That's better. Alright. So here I can probably go load. Oh, you know what? Save fonts. And we'll call this first sortie. Or come on. First sortie. Alright, so we're going to come here, load first sortie. Into the other two control nodes. Ah. Dodge the slimes. Okay. So here, actually, I want to make this even bigger. Oh. Okay. So we had 60. Make unique. 128. Dodge the slimes. Save. Okay. Arrange the nodes as shown. Although I do like the idea of kind of bringing this down here a bit. And let's just... yeah. That'll be good. Okay. I can close that now. Okay, you can drag the nodes, place them manually, or for more precise precision, use the following settings. Blah, 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 blah. No. Alright. On message timer, set the wait time to 2 and the one-shot property to on. Now add this script to the HUD. Extends canvas layer, signal, start game. So now we have a signal we can send out, and we can actually connect that up to the start game function that we made earlier. I'm actually having a lot of fun with this stream, guys. Okay, so now the start game signal tells the main node that the button has been pressed. Func show message text message text equals text message show, and then message timer start. Okay, so that will let me dynamically change the text. So when the character dies, I can say game over, and when he presses the start button again, which we could probably also do, try again. All right, so func show game over. Show message game over. yield message timer timeout. Okay, so wait until the message timer has counted down, and then message dot text equals dodge the slimes. So we're returning the text to what it was originally. Message show. Make a one-shot timer and wait for it to finish. Interesting. All right, yield get tree create timer 1 timeout start button show. Okay. This function was called when the player loses. It will show game over for 2 seconds, then return to the title screen, and after a brief pause, show the start button. Okay, I'm getting this. Func update score label text equals score. I'm guessing. No. String score. We're forcing it into a string. That makes a lot more sense. Okay, so the next this function is called by the main whenever the score changes. Connect the timeout signal of message timer and the press signal of start button. Okay. Alright, on start button press, start button, hide, emit signal, start game. And then we need message hide. Alright, so now we need to connect this to the main world. So now that we're done creating the HUD, go back to the main and instance the scene HUD, the HUD scene. There we go. Okay. Alright, that's all looking good. Now we need to connect the HUD functionality of to our main script. So, this requires a few additions to the main scene. In the Node tab, connect HUD start game signal by typing new game in the Connect. Alright, good. Verify the screen. Yep. Alright. In new game, which is where we are at, update the score display and show the get ready message. Alright. So, HUD update score. Score. HUD show message. Get ready. Alright, in game over, HUD show game over. Finally add this to the on score timeout. And I'm not even going to look at it. HUD. No. HUD, not hug. Update. Okay, now you're ready. Click the play project button. Game over. Dodge the slimes. Start. Wait, what? Okay, I think something broke. Oh, that's because we still have a new game up here at the top. Alright. Yeah, now it's going to work fine. Get ready. Game over. Dodge the slimes. Start. Get ready. I'm so ready. Yeah, if we increase the quality of the graphics of this a bit, maybe make the characters bigger. I don't know. Yeah, let's try that. Let's make the characters bigger. So, let's go to the player scene. I'm gonna say right there is good enough. Alright, so the slime is now 3 times as big. What about the player? Well, let's make him 3 times as big too. Because, I don't know, 3 just sounds like, yeah, it might work. Oh, crap! No, this will not work. This will not work. This will not work. Yeah. Okay, yeah, they're too big. Definitely too big. Okay, let's take this down to 2. And we might find that even this is too big. But you never know. We might even just want to make the slimes themselves smaller. Oh yeah, that looks good. Ooh. Okay, so for this, I actually do want to come back to Game World and change the mob timer. Let's take this to like the 5.0 that they originally specified. Now let's see how it does. Now, something I would like to do is actually make this get progressively harder. So, the longer you go, you know, it will start to ramp up. So, how could we do that? Hi, Sociable Steve. I'm doing pretty good. I'm learning how to use Godot, so this is kind of fun. I just made a whole game. Yeah, here it is. Here's the game. It's, you know, dodge the slimes. We have this crappy little guy I made, and my crappy little slimes. But, you know, I can just come through here, and I gotta dodge them, and the longer I keep going, the higher of a score I get, which is up here. But I want to make this tougher. I want to make this hard by slowly scaling up the amount of slimes that get spawned. There'll be an upper limit, I think, but... It's like, how can I put this on a linear gradient? I want to warp it. Because this feels good for a starting point, but I definitely feel like they should definitely get harder. If you can make a score of over 60, you deserve to, even with it getting harder. Yeah. So, all right. So let's go to the scripting. Okay, we have process, which is run every frame. Okay, so no easy answer. Okay, so delta is the total number of frames. You know, called every frame. Delta is the elapsed time since the previous frame. So we actually need a new variable here. Actually, no, we can use score. That's our variable. No. Yeah, we'll do that. All right. So, what we want to do now is if delta lerp. We'll keep it. if score is greater than 20. Okay, good, that works. All right, if score is greater than 20, now we start our lerp. Actually, no. If score is greater than or equal to 60, mob timer wait time equals 1. We'll be able to modify this later. Yeah. Alright, var max time, max wait equals 1. Var min wait equals 0.5. So now I can just come in here and, you know, if it's over that, that's great. Else, if scores under 20, if score plus delta, that's what it was. Var SD equals score plus delta. Var game time. That's what it's going to be. So, in truth, game time plus equals delta. So this should, and I do emphasize should, unexpected statement. Is there an else if in Godot? It's if. I just need to know their language. Alright. Game time equals 0. So this, you know, just the game time bonus thing, that should give me a whole lot of information. So if game time is greater than or equal to 60, then the wait time equals max wait. If it's less than 20, wait time equals min wait. Else, mob timer wait time equals lerp lerp min weight, max weight, var timeline equals 1.0. Alright, so now we can do the math for that. So game time minus 20. Or no, it's game time divided by 20 divided by 60, or 20 minus 40. Game time divided by 40. So if it's no. $80. It's game time divided by, oh no. Game time plus 20 divided by 80. So that is our time frame. Because game time has to be a minimum of 20. So, and then we divide that by 80. No. Okay. I know how to do this. Minus game time minus 20 divided by 40. So over the course of 40 seconds. So var end time equals 60. And start time equals 20. So start time, end time equals start time equals end time minus start time. There we go. Alright, so now it should lerp quite a bit. And I'm going to make this insanely big so it's easy to know if it's actually happening. Come on. Okay. Save, play, start. Okay, now that worked. Let's try that. No? Okay. Alright, so game time equals... I'm going to create a new timer here. Game timer. Wait time is 0.1. So every quarter of a second, we're going, or every 1/10 of a second, we're going to update this. So, game time plus equals 0.1. So no more delta work. Alright. Alright, so is there a set? Set. Wait. No? Okay. Alright. Var is started. Var is started equals false. If is started equals true. Is started equals false. Is started equals true. All right. There we go. So, yep, starts out at a nice, even, slow pace. So let's see if they really start to spawn here in a moment. Okay, now they're going to start ramping up. There should be a lot more being spawned. I don't think it's working. All right. All right. Alright, so yeah, we're going to end this loop if we're already past our end point. So now it should be really insane really fast. No. Or do I have the wait times backwards or something? Yeah, I think I do. All right. Else if game time modular 0.1. Actually, yeah, let's just turn this off. Come down here. I mean, we've got the point timeout anyways. So what we need to probably do is probably hit it with that whenever we change the wait time. Okay, now this will go nuts. It might go nuts anyways. Oh, I was bad. I haven't even gotten to the faster. Okay, that looks like it's going faster to me. Just a little bit. Maybe not. Let's come here. 0.05. Alright, that was just nuts with the... Yeah, it's definitely not doing that. And there's no way you can win with 0.05. Alright. So, let's check... Godot. Change timer wait time. All right. Timer I'm using is limited to blah 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 blah. Oh, is it set to auto start? No, it's not. Oh, there's a print function, huh? Alright, let's see what this does. You know what? I forgot to start this. Game timer, start. And game timer, stop. Alright, so now this should lerp correctly. Let's see, let's see if the print does too. Oh, it's actually printing down here. Oh, look at it, it's lerping. It's lerping. All right. So copy that, paste that in here, set that to min weight. Let's stop it and then start it again. All right, let's try again. Okay, so probably because the gamer timer is different from the mob out timer. So what we actually need to do is we're just going to take this whole code. And we'll just toss it into the mob out timer. So I'm wondering if it will work without the stops. Let's find out. It looks like it's working. Yeah, that's working all right. Okay. So now we can find a little bit better values for this. Like, you know, we'll take it down to like maybe 0.1. But I can also remove that. We can also say, you know, we can also start at like 10 and go till 60. But let's keep it 5 and 20 for the moment. Alright, it's going to start scaling up now. Do, 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 do. You know, that actually looked like a decent amount at 20. Aha. So yeah, it is possible. It's just really hard. Oh. Our collisions are gone. Alright. So... what happens if I just start again? And if I start again now... do I have collision? No. Collision somehow gets turned off. Okay, I don't need is started anymore. Oh. Yeah. It's nice that it tells me that. And let's put our vars up here. Alright. Speed up variables. Okay, wait time equals minimum. So we're resetting the wait time just in case that's a concern. All right. Okay, I died. I lost. It's over. That's fine. What about now? Now I am freaking invincible. I will last forever. So, do the mobs lose their stuff, or does the player? Oh, look at that. On player body. Okay. So this disables our collision after we get hit. So we need to actually change that back. So I wonder if it works with ready. Does ready affect things when you reset it? I don't know. Alright, well, let's create a new function here. Function start_game. Set deferred. Can I just do set? Alright, so now alright. So player start game. Okay. So let's see if that was the issue. So I died. Yes. I died again. So that was the issue. Yeah, it disabled me, and then I was invincible. So we fixed that problem. Yay! Okay, guys. We actually did quite a bit. Not as much as I would like, but yeah, still, we made a game. I mean, you know, how many people can say they made a whole game on one stream? And it was pixel art and everything, and you know, I made a slime. I made a slime. So I'm definitely going to have to go through here, learn how to do this, and I'm going to probably try and create the start of a nice little background so we can have a place to put our guy. You know, we need an environment for him to work on. We got to work on getting that 2.5D system going on, that, you know, or that 2D system that, you know, everybody has, where the collision is, you know, lower than the actual size of the house. So all that kind of good stuff. All right. Thank you all for joining me. I will see you next time, which will be Friday. I don't think we're going to be doing this, but I am going to work on this. I'm going to work on building my Stardew Valley clone. And that's probably going to be when I'm not, you know, playing Graveyard Keeper. I just absolutely love that game. I thought about playing it with you guys, but then I was like, oh, god damn it. I started on the PlayStation. I just started on PC. I don't want to start again. At least not right now. But, you know, that'll be, you know, that's Friday's headache. Maybe we'll get back to this on Friday. I don't know. This is a lot of fun. And I'm learning quite a bit. So, working on this is going to be very interesting. Of course, I've got other things I got to work on. But learning Godot is actually kind of fun. And for a 2D game, I think it's probably going to be worth it more than trying to figure out Unreal Engine's version of it, even though I know a lot of the back end of Unreal Engine better. So who knows? All right, guys. Thank you all for being with me tonight, and I will see you Friday. Yep. Good night, everybody.